Okay.
So your logistic differential equations are used to measure population growth of
Mhm.
animals. Like that's just one application of this. There are many real world applications, but mostly you will see the growth of animals is with respect to time is measured using a logistic differential equation. So you should, first of all, for AP exam, you should know a couple of things. First is you should know the graph of the logistic differential equation. So whenever we have population of animals or even human beings, when the times is increasing, the population will, you will see that the population starts increasing. You will see a growth. There will be growth, 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 growth. And then after a certain point, you will see that the population will reach a certain number and it will stop increasing beyond that number.
Okay.
It is actually, it starts approaching a number. You get a horizontal asymptote around a number.
Mhm.
So let's also define the y-axis and x-axis. So your y-axis is population and the x-axis is time. So as time increases, first you will see that population increases. This is applicable for any living creature, insects, human beings, animals, okay? This
Okay.
has been observed in all the living creatures. So first, the growth rate increases. This is your growth rate.
Mhm.
It will increase and there will be some point in the middle. Can you see that after this point, the concavity is changing? See, before this point, the graph is concave up. And after this point, the graph becomes concave down. Okay.
Mhm.
Now, this line that you see, this line, this is called the limiting value. The
Okay.
population will not go beyond this limiting value. It is also called carrying capacity.
Okay. Carrying capacity.
Yes. Okay. So first, the growth rate will increase quickly, and then it will slow down as the population reaches the carrying capacity. So this is your concept of logic. And in AP exam, they will not ask you to solve the different logistic differential equation, but they'll only test the
Mhm.
concepts. Okay.
Okay.
So there are three main concepts here. First is the concept of limiting value. This is the maximum population. Okay. Now, I'll tell you the differential equation as well. The differential equation is given by dy over dt equals to ky times 1 minus y over L.
Okay.
You will also have some questions in which you have to identify which of the given differential equations is a logistic differential equation. So you should know the forms of logistic differential equation. This is one form. Here, your capital L is the carrying capacity or the limiting value. Okay, this is your carrying capacity.
Oh, carrying capacity. Okay, got it.
And another form of this differential equation is dy over dt is equal to k
Wait, carrying
over,
capacity is asymptote, right?
yes. So this line is your y is equal to capital L.
Okay.
This is a horizontal line. And if you just manipulate this equation algebraically, you will get another form, which is k over L times y times
Mhm.
L minus y. Both of these are equivalent.
Mhm.
Okay, so these are the two forms of logistic differential equations. And you have to memorize these forms. But if you know one
Okay.
of these, the other one you can find out by just doing basic algebra. Like if you know this, you factor out L from this equation. If you factor out L, you will get this equation. Factor out L, you will have 1 minus y over L, and L will get cancelled. You'll get this equation. Okay.
Okay.
Okay. So here are a couple of concepts that you need to know.
Mhm.
Well, there is also law of natural growth and decay. This is the exponential growth model that you said.
Okay. Yeah, I see.
Rate of change of y is proportional to y. This is exponential growth.
Mhm.
And This is not tested on the AP exam, so you can ignore this, but you should know this. And solution of this is y is equal to c times e raised to kt. Next is, so we will, like this week, we will be doing all of these topics. Slope fields. Have you also done slope fields in school?
Yeah.
Okay. Slope fields, differential equations, Euler method, and logistic growth. Now, this is logistic growth models. Here are the two equations that I told you. Okay. And the carrying capacity, you can also find out the carrying capacity by taking the limit of y and when t approaches to infinity. What does this mean? T approaches to infinity means when time is so long, like infinitely, when you're moving infinitely in time. So your population, which is y, that will reach to capital L. Like after some point, see, this graph will approach to this horizontal line. Okay, so that's why we are saying t approaches to infinity, limit of y will be L. Now, the fastest growth rate. The growth rate, now you have to see this graph really carefully. This blue graph, actually kind of purple. So from 0, the growth rate is increasing. See, this is increasing. And at this point, this is your point of inflection.
Okay. Point of inflection.
You would have done point of inflection in AB classes.
Yeah, it's when like it becomes from increasing to decreasing.
No. This is a point where the concavity changes.
Wait, same thing though. Actually, no, yeah, concavity. Yeah, you're right.
So before this point, the growth rate is increasing. And after this point, the growth rate, it is still increasing, but the rate of increase is less. The rate of increase is less than the rate of increase before this point. So the rate of increase will be maximum at this point. And this point happens, like this point is exactly in the middle of the carrying capacity. So if this is L, so this point will be L over 2. Okay, always. And you see that this is 500, this point is 250.
Okay.
So at L over 2, you will get the fastest growth rate. Okay. These are the only concepts which are tested on your AP exam. They will not ask you to solve the equation. Okay. But just conceptual things. The fastest growth rate occurs when y is equal to L over 2. Okay. And you can see that before this point, the graph is concave up. So concave up means that the rate of increase is increasing. Y is increasing at an increasing rate. And the algebraic condition is double derivative is greater than 0. This is the condition for concave up.
So if the second derivative is above 0, then that means that there is a point of inflection, right?
At point of inflection, double derivative is 0.
Oh, is 0. Okay.
Yes. But when the graph is concave up, so when you do this, you get the candidates to check concave up and concave down. And then when d2 double derivative is positive, then you have concave up. When double derivative is negative, then the graph is concave down.
Okay.
And the meaning of concave up and concave down is that the growth rate is increasing at an increasing rate. And concave down means y is increasing at a decreasing rate. So this happens when the y value is less than L over 2, right? Because all the points here are less than L over 2, the y values. And above this point, the y values are greater than L over 2, but they will be less than capital L.
Okay.
Okay. This is the only thing that you need to know for logistic differential equations. And now we will do some questions on logistic differential equations first. Okay, see the first one. Which of the following is a logistic differential equation?
So we need an L and then we all have L. So
first you should write the equations. dy over dt is equal to ky times 1 minus y over L. And if you distribute this, you will get dy over dt is equal to ky times L minus y. No, not distributed, but I think you should just remember this equation. Then we ky times L minus y. And once you know this equation, if you factor out L,
Mm-hmm.
so you'll get this equation. 1 minus y over L. L is missing here, wait. You factor out, okay, you factor out L, so 1 over L, okay. Okay, so we have 4 answer choices. We have to see which of these answer choices represent a logistic differential equation. And I think in all of these look similar to the first form.
Yeah, they're all
Right?
based on this. Yeah.
Okay,
So I was thinking it was C initially, and
C.
I still agree with that because it has a minus. It
Mhm.
has the Q where it's supposed to be when it's DQ.
Yes. It's not going to be definitely not D because there is a W square. Okay. It's not going to be B because the dependent variable should be also there. So if it was 3 times R, then it would have been correct. And it's either A or C, but it cannot be A because there is a plus sign. We want a
Okay.
minus sign. So it is C. It says a hilarious meme about Brian and Tony is spreading among AP calculus students. The number of students that have seen the mean follows a logistic curve modeled by the function S of t, where t is the time in days. The number of students that have seen the mean is increasing at a rate of 125 students per day when S reaches half the carrying capacity of 5,000 students. Which of the following is the logistic differential equation for ds over dt?
Okay.
Okay. So all of these are the logistic differential equations. What was the general form of logistic differential equation? dy over dt is equal to ky times L minus y. And what was the other form? Factor out this L.
Factor out the M. Wait, what M?
L, L.
Oh, wait. Oh, okay. So LKY times 1 minus Y.
Hmm.
So L.
LKY times 1 minus y over L. Okay. Now L and K is another constant, right? L is a constant, K is a constant. So we combine L and K and we just write it as K times Y. K times Y. Where this time your K is the product of the original K and L. Okay. So in all the answer
Okay.
choices, they have used the second form, this one. Right?
Yeah.
Okay, now we need to write the exact differential equation. That means we need to find the value of K, we need to find the value of capital L.
Okay.
Okay, so read the question again. See, we have some stuff going on here. We have this number, we have this number. What are these numbers? The number of students that have seen the mean is increasing at a rate of 125
So
students.
125 will be like the L, right? No.
No,
No, that's a rate. Huh?
This is the rate.
Okay, so that's what, K?
No, this is rate at which the meme is spreading. So that's actually your ds over dt. ds over dt is 125. This is happening when S reaches half the carrying capacity of 5,000 students. So what is the carrying capacity right now? What's the carrying capacity? This is the carrying capacity.
Mm-hmm.
This is the carrying capacity. So that means this is L. Okay.
Okay.
So your differential equation becomes all of this y over 5,000. And your dependent variable is S. So instead of y, you can write S. Okay. Everywhere, wherever you see y, write S.
Mm-hmm.
ds over dt is equal to k times S, 1 minus S over 5,000. Okay. Now it says the rate of increase is 125 when capital S reaches half the carrying capacity. So what will be half of the carrying capacity?
What will be half the carrying capacity?
Hmm.
Mm,
That means half of 5,000.
2,500.
2,500 exactly. Okay, so that means when S reaches half the carrying capacity, when S is 2,500, at that point, ds over dt should be 125. So what you need to do is, you have to put S is equal to 2,500 in these answer choices, okay? And see wherever, so for example, in answer choice A, put S as 2,500, 2,500, okay?
Mm-hmm.
So in whichever answer choice you get ds over dt as 125, that will be
Mm-hmm.
correct.
Okay. ds by dt as 125.
Hmm.
Okay. Got it.
Okay, so let's check answer choice A. 1 over 10 times 2,500 times 1 minus 2,500 over 5,000. Can you solve this?
Mm-hmm. 1,000.
And one more thing is, you can eliminate answer choice B and C.
Yeah, I see.
Why?
Yeah.
Because here L is 2,500. No, L is 5,000. So it's either A or D, because in A and D, L is 5,000.
Okay. Yes. Because the carrying capacity. And then um the wait, the answer is A, right?
Did you get 125?
Yeah.
250, and this will be 1/2. So 1/2. So 1/2 of 250 is 125. So it is answer choice A. Okay. Are you getting a hang of this concept?
Wait, how's it A? Isn't it B?
You're getting D?
No, D.
You're getting 125 in D?
Yeah.
How? Let's do number
But
D.
how's it 1/10? That part I don't get it.
So you don't have to find out the value of K. See, this is the value of K, but you don't have to find out the value of K. You just put the value of S, and whichever equation gives you ds over dt as 125, because it says the
Mm.
number of students that have seen the meme is increasing at a rate of 125 students per day. This 125 is actually the value of ds over dt.
Oh.
So whichever equation gives you ds over dt as 125, that will be our answer choice.
Oh, okay.
If you'll check D, you will not get 125. It looks like you'll get 125 because they have included 125 as the coefficient. But if you really check, put S is equal to 2,500, you will not get 125. 125 times 2,500 times 1 minus 2,500 over 5,000. All of this is 1/2.
Mm-hmm.
125, then 1/2 of this. That will not be 125. 1250. Tanvi, did
Okay.
you understand this question? Like, really understand this?
Um Actually no, now I do, because I just got the L. I got the one, I understood the 1 minus S over L, and L is 5,000. Now I got to understand the 1/10. So
Got
yeah.
to 1/10. You don't
Yep.
have to. You don't have to worry about the 1/10 part. We just have to see which differential equation will give us this rate.
Yeah.
Okay. Let's
I
see
got
if
it.
we have more question. We have one more question on logistic differential equation. Okay. A population of meerkats grows according to this logistic differential equation, with M representing the number of meerkats at time t in years. Which of the following statements are true? So we have three statements. We have to see which of the three statements is true. So this is again a conceptual question. You don't have to solve anything. This is purely conceptual question. Okay, so this is a logistic differential equation. Can you write it in the form of like the general form dy over dt is equal to ky times 1 minus y over L. Can you write it in this form?
Um,
The only difference is instead of y, the dependent variable is m.
okay. So dm over dt equals 3,
Factorize m.
yeah,
See, okay,
3m 1 minus 0.1 m, not
see, you
squared, because
need
you,
a 1 inside the parentheses, okay? So factor out 3m. That's only you'll get, that's when you'll get 1.
okay, yeah.
Factor out a 3m, so what do you get?
Factor out 3m, you just get 3m 1 minus 0.1 m.
0.01m?
Yeah.
No, see, you have factored out 3m.
Oh,
Not,
so well, 0.01 over 3.
yes, 0.01 m over 3. We can simplify this. So dm over dt is 3m times 1 minus 0.01 is 1 over 100. So 1 over 300. So m over 300. This is now in the general form.
Okay.
Okay, Tanvir. So what is the carrying capacity for this equation? That means what is the value of capital L?
300.
300. Good. L is 300. And now they will ask the interpretation of this 300. Now see, let's read the answer choices. First, if M is greater than 300, the population of meerkats is decreasing. Do you think this statement is correct? We'll go back to a table that we did see. This
I
table.
think it's correct.
It is correct. So beyond this point, see, this is the total graph of complete graph of logistic differential equation. Beyond this point, like above L, this is the graph. This means that the population is decreasing. When
Yep.
L, I mean, when Y is greater than L, when your Y is greater than L, at that time, Y will be decreasing.
Okay.
What are the other things that we saw here? That means when Y is exactly equal to L, then
Why is exactly good at all?
when Y is this point, 250, then the rate of increase of Y will be the fastest. Rate of increase of Y will be the fastest. Okay, now let's do the problem. Okay, so first statement is correct. When M is greater than the carrying capacity, when M is greater than L, the population will decrease. This is correct. Second, the rate at which the meerkat population is growing is greatest at n is equal to 150.
Okay.
Okay, I think I wrote L here. This is L by 2, L over 2. When Y is equal to L over 2, that means half of the carrying capacity, the rate of increase will be fastest. Let's go back. Greatest, see, the population is growing, is greatest. That means they're talking about the fastest growth rate. So you'll get the fastest growth rate at which point?
At
I wrote it
m equals.
at L over 2.
Oh yeah. Oh, that makes sense. L over 2. So
L over 2, okay?
And your L is 150.
No, L is 300.
Yeah, so then half L over 2 is 150.
Yes, L is 300.
So
So M
two
will
is
be 150.
true.
So statement 2 is also correct.
Yeah.
And the statement 3 says limit of M when t approaches to infinity is 300. Well,
Yeah.
this is correct. This is just the definition of the carrying capacity.
Yeah.
Limit of the dependent variable when t approaches to infinity, that gives us L.
Hmm.
So this is correct.
All right.
So all the statements are correct.